Okay, here we go, boys and girls. This is the Unit 1 review of Algebra 2. Again, by now, it's obvious that, again, the problems that I do on these videos and on my assignments are going to be similar, but there's a great chance that they'll be just a little bit different than yours. They choose their problems from a collection of questions at random. So I don't know exactly what they're going to ask you. However, I would bet that many of the questions are very similar. So again, I will try to explain the best I can the idea behind the problem, so you can take what I do on my problems and apply them to the problems that are similar to yours. However, also because this is a review, I'm going to be working just a little bit quicker than what I normally would. If you need a deeper understanding or a deeper meaning, take a look at some of the previous videos and they will help you out a little bit more specifically for this specific topic. Okay, here we go. In this very first problem, I take this, the problem, and I break it apart. So the first part, I see that negative 5x like that. And the other part of the problem, I see that I have x is less than or equal to 1. All right, take a look at where the x is. So again, the distance between the bars, this is on the big side. So x is bigger than the negative 5. All right, and here, this is on the small side. So x is smaller than 1. So it's bigger than negative 5 and smaller than 1. All right, so let's go to the negative 5. So negative 5, it has the or equal to bar, so I darken in that circle. All right, so it's bigger than, so that means the numbers are bigger than that. Okay, I go to the 1. And again, it's or equal to, so I darken in that dot as well. And it is smaller than 1. So it's all the stuff smaller than 1. So I go ahead and just kind of link these two things together, and that would be the graphical representation of that statement, where x is bigger than the negative 5 and smaller than the 1. All right, this next problem we have f plus g. I think this might be a question from last chapter, but carries over. F is x minus 4. G is 2x squared plus 5x plus 1. So this is f plus g. So with this plus, there's no real funny business going on. We just put all the correct things together. So I have x squareds, I have x's, and I have normal numbers. So of my x squareds, I have 2. So I have a 2x squared. The x's, I have a 1 and a 5. So 1 and 5 are 6. The normal numbers, I have negative 4 and positive 1. So that's going to be negative 3. Okay, so we are given the picture of a quadratic. That's a picture of an x squared. And so we need to manipulate this just a little bit. So I see that there's a negative, so that means there's a flip-flop. And then an outside plus 3, so that is an up 3. So the x is y, not the x is y, not the y. So that's on the outside, that's a y motion. So what I do is I do all the motions, all the pluses and minuses. So I go up 3. 1, 2, 3. Okay, and that's my new start, up 3. Then typically it would go up like a U from that point, but because of the flip, it's going to open downwards. And again, this is a 1, 3, 5. So from my dot, it'd be 1, 3, 5. 1, 2, 3, 4, 5, 7. No, don't have them 4. 1, 3, 5. Oh, grand distances of 1, 4, and 9. Okay, domain and range. So what I see is this has an arrowhead going in that general direction, right there. This is infinity, this is infinity, this is negative infinity, this is negative infinity. Okay, the domain is the left to the right. So the leftist is negative infinity. The rightist is positive infinity. So that goes from negative infinity, so left to right. Don't accidentally write it right to left, left to right. And the range is the y. So domain is the x, range is the y. So bottom to top. Bottom is negative infinity, top is positive infinity. So domain and range, left to right. Range is bottom to top. Okay, here they start us off with an f of x being x plus 3 squared minus 1. And what do they want us to do? They want us to move that right 6 and up 2. So right 6 is going to be a minus 6 in with the x. So x is a left-right kind of idea. And it's opposite. So you would think that in the x, okay, this is the positive direction, this is the negative direction. So if you want to move right, you would think, oh, that would be a plus 6. But the x's lie. The x's lie. Oh, if you want to move it to the right, you actually have to minus. The x's lie, but not the y. So again, a y, okay, plus minus, is exactly what you want, what that is. So if you want to move it up, that would be a plus. If you want to move it down, it would be a minus. So here we go. I'm moving it to the right, 6, and up 2. So that updates our function here. And this is going to be x minus 3, so 3 minus 6. And then this would be plus 1. So I took that given function and I moved it right 6 and up 2. Okay, zeros. Again, what a zero is where does it touch the x-axis? I don't care where it touches the y-axis. Where does it touch the x-axis? And I see that that is right there at the point 2, 0. Okay, here we go again. So x. Okay, look at the distance. This is on the big side of those sticks. So x is bigger than or equal to 5. So I go to 5. Because it's or equal to, it has that line underneath. I darken the circle. Otherwise, it would be an open circle, like not filled. And we want that to be bigger than 5. So it's all the stuff bigger than 5. Okay, so here I have an arrowhead, which is generally going in that general direction. I have another arrowhead that is going in this general direction. Okay, so if it goes up, it's infinity. If it goes right, it's infinity. If it goes left, it's negative infinity. If it goes down, it's also negative infinity. All right, so the domain, which is the x, the leftist thing that I have is negative infinity. The rightist thing is positive infinity. The range, bottom to top. The bottom is negative infinity. The top is positive infinity. Okay, so from the original picture right here, from the original picture, what I notice about this is left 1, 2, 3. It's left 3. And I also see that it's down 2. The distances are 1, 3, 5, so that isn't manipulated. So we're all good right there, and it's a good U shape. All right, so I have to move this equation left 3 and down 2. So left 3 is an x. You'd think that it's a minus, but the x's lie. So that would be a plus 3. Down 2 is an outside minus 2. So that's left 3, down 2. Okay, increasing, decreasing. Draw this as it's going left to right. Here I draw it's all down, and then from there it goes up. Again, I'm not saying how high and how low it goes, but rather you need to talk about the x. So this x is at -2. Not the y. I don't care about the y. So increasing and decreasing has nothing to do with the y. I don't want to see a y coordinate. All right, so the picture begins by decreasing. So it's technically decreasing from -infinity. So -infinity all the way to that -2, it's decreasing, and then it turns into an increasing from that -2 to infinity. All right, again, I have an arrowhead that one's going in that direction, so that's going to the right and up. And I have this arrowhead, which is going this direction, so that's going to the left and up. The domain. The leftist that I have is -infinity. The rightist that I have is +infinity. The range. The lowest that this thing is -9. The lowest thing that I have is -9. The highest thing that I have is infinity. Okay, end behavior. This is going up, and then this just stops. So none right there. All right, so when it goes to +infinity, that means as this thing, what's happening on the right-hand side? As x goes to -infinity, that is asking what is happening on the left-hand side. Okay, on the right-hand side, I see that this is going up. That means it's going to +infinity. On the left-hand side, I see that it abruptly stops, so none. There is no end behavior there. Maximums and minimums are tops of any hills or abrupts, tops of any hills, bottoms of any valleys, or anything where the thing abruptly stops. Okay, these are the three things that you're kind of looking for. So where are the tops of any mountains, bottoms of any valleys, and where do things distinctly stop? So I do have a top of a hill, and I have two bottoms of valleys. Nothing abruptly stops. Okay, if it's at the top of a hill, it's a max. So I do have a max here, and that is at the location of 0, 9. And I do have minimums, and I have two of them. And those occur at -2, -9, and +2, +9. Or excuse me, +2, -9, I'm sorry. +2, -9. Inverse, again, I think this is the last chapter, I think, maybe. So y is equal to 2x minus 8. Inverse means x is, no, actually, this is this chapter, I'm sorry. X's become y's, y's become x's. So x is equal to 2y minus 8. So please excuse my dear Aunt Sally backwards. So is there anything subtracting the x, or excuse me, subtracting the y? Yes, there is. There's a -8. So that means I have to add 8. So by adding that 8, it gets rid of the -8. Is there anything adding to my y? No. Is there anything dividing my y? No. Is there anything multiplying my y? Yes, there's a multiply of 2, so I need to divide by 2. Okay, so y is equal to x plus 8 divided by 2. All right, so what's the answer? The original symbol is an f of x, so I denote that as being an inverse, and it's x plus 8 divided by 2, or in other words, 1 over 2x plus 8 over 2. 8 over 2 is the same thing as saying 4. That, I'm assuming, is the answer. So this was x over 2 plus 8 over 2, which ultimately is x plus 8 over 2. That's what the answer was. So that's x over 2 plus 8 over 2. 8 over 2 is the same thing, same thing. All right, so write an equation of a quadratic. A quadratic is an x squared that goes right 2 and up 1. Okay, so here we go. So quadratic, that is right 2, so x is lie, so that's right 2, up 1. Identify all the zeros. Again, what a zero is anywhere that it touches the x-axis. So I see right there, which is occurring at -1, 0. That's the only time that it touches the x-axis. Okay, again, any zeros, I see that it touches right there. I don't know exactly what it is, so let's it's about like 1.5. So -1.5 is approximately where that is. Like -1, not quite 2. 1.5. Okay, increasing and decreasing. So I start here. Notice how it's going uphill this entire time. This whole thing is increasing. So again, I don't care about how much it's increasing. So this is occurring at -1. So this picture is increasing from -1 to infinity. Again, I don't care how much it's going up and down. I have to define this as being intervals in the x, not the y. So there is no y coordinates. It's all going uphill. Left to right. Don't ever go right to left. Okay, now, eventually, yes, this thing probably does have a 0, but notice how this is asking for on this picture. So take a look at this picture. Does this ever touch the x-axis? No, this never touches the x-axis. So where are the zeros? None. This isn't showing any. Yes, it probably will eventually, but on this picture, there aren't any zeros shown. Typo. End behavior. Typo. All right. So again, as x goes to positive infinity, that's saying to the right. As x is going to, that means to the left. All right, so this right-hand side is going down, this left-hand side is going down. All right, so what is the right-hand side doing? It's going down. So that means it's going to negative infinity. It's going down. What's the left-hand side doing? Oh, the left-hand side is also going down. So that means it's going to negative infinity as well. So up is positive infinity, down is negative infinity. Increasing and decreasing, so I see that will switch right here, which is at -2. -2 is where the switch is. So this is all increasing. This is all decreasing. So we're increasing going up to that -2, and then we're decreasing going away from that -2. So we're increasing from negative infinity to -2, and then we're decreasing from that -2 to infinity. Okay, this is a picture of a square root. They want you to graph this as a square root -1. Notice how it's on the outside, so that'll be down 1. So I start here, and then I go out 1, 3, 5. And there it is. Okay, this is where it stops. So this is the important mark right here, and that has an x-coordinate of -1. So from here, this is all increasing. Nothing happens to the left of -1. This is all increasing. It's all going up. So this picture is increasing from -1. Technically, it should be a square bracket. Don't worry about it. To infinity. Decreasing. It's never decreasing. This is never, ever, never, ever decreasing. Okay, give the inverse of the graph. What an inverse means is x's become y's, y's become x's. So what I do is I pick out some important points. Okay, I'll identify these points going from left to right. So I see that I have -6, -5-ish. I have -2, -4. I have 0, -3. I have 1, -1. I have 2, 1. I have 4, 2. And I have 6, 2.5. Okay, so the inverses is where the x's become y's and the y's become x's. So instead of -6, -5, this would be -5, -6. Instead of being -2, -4, this is -4, -2. So with those inverses, I can go ahead and graph these. So -5, -6. -5, -6. -4, -2. -3, 0. -1, 1. 1, 2. 2, 4. and 2.5, 6. All right, domain and range, I see that this point is at 2, -4. And I see that we have an arrowhead, so this goes to positive infinity and negative infinity. All right, so the domain, the leftist thing that I have is, sorry, -2, negative. The leftist thing that I have is -2. It's a solid dot, so it's a square bracket, -2. The rightest thing that I have is a positive infinity. Range. The lowest thing that I have is a negative infinity. The highest thing that I have is a -4. Okay, here I have one arrowhead, so this is going negative infinity, and then I have an open dot at this 6, 2. Also take note that this is technically the highest point. Okay, this has a height of 3. All right, so take note that we'll have to take that into account. All right, so the domain is the leftist to the rightist. So the leftist thing that I have is negative infinity. The rightist thing that I have is 6, but it's an open dot at that 6, so it gets a round bracket. Range. The lowest thing that I have is negative infinity. The highest thing that I have is 3. It goes through that 3, so that's a square bracket. Because notice how 3 is higher than that point right there. Okay, it's the lowest to the highest. So that dot is higher than that dot right there. So again, I need to know the lowest and the highest. Okay, so we need a quadratic, so that's an x squared that is reflected. Down 6, right 5. Quadratic that is reflected. Down 6, right 5. Okay, so there's our quadratic. So it's reflected. Down 6, right 5. And again, the x's lie. So again, x's, typically this is positive and this is negative, but if I need to move to the right, it's going to be a minus, because the x's lie, not the y. The end behavior, I see that this is going up, this is going up. If there's any stops, then it'd be none. And so the positive infinity is asking what is the right-hand side doing. The negative infinity is asking what is the left-hand side doing. So on the right-hand side, okay, on the right-hand side of this picture, it's going up. So that's going to be positive infinity. It's going up. On the left-hand side, it is also going up. So that's going to a positive infinity, because again, it's going up. So again, this is the right-hand side. This is the left-hand side. Okay, domain. This is the leftist point. This is the rightist point right there. So the left to the right. So the leftist thing that I have as the domain is -4. The rightist thing that I have is a positive 6. Notice how it's a closed dot at the -4 and an open dot at the positive 6. So that's the domain. The range, the lowest thing that I have is that. The highest thing that I have is that dot right there, which is technically at 0, 4. That's the highest dot that I have in this picture. So the range is the lowest which is at -5, and the highest, which is at 4. It's an open dot at the -5, and it goes through that 0, 4, so that is a square bracket on the 4. Maximums and minimums, what I'm looking for is any tops of mountains, bottoms of valleys, or anything where the picture abruptly starts or stops. Okay. So I have a top of a mountain and nothing else abruptly starts or stops. So that's the only thing. Because it's the top of a mountain, that is a maximum. So this has a maximum at the point 1, 2, 3, 4, 5, 6, -2. Yeah, 6, -2. And there is no minimums. There is no bottoms of anything, so none. I think that's it. Easy peasy.